Reflection is a fundamental behavior of waves, and it occurs when waves encounter a boundary or surface and bounce back rather than passing through or being absorbed. All types of waves, including light, sound, and water waves, can be absorbed, transmitted, or reflected depending on the properties of the material they encounter and the angle at which they strike the surface. When a wave hits a surface, some of its energy may be absorbed by the material, causing the material to heat up or vibrate. This absorption reduces the intensity of the wave that continues to travel. If the material is transparent or partially transparent, part of the wave may be transmitted through the material, continuing its journey on the other side. However, if the material is opaque or highly reflective, the wave will bounce back into the medium from which it came. This bouncing back of the wave is what we refer to as reflection. To visualize reflection, one can draw a simple ray diagram, which is a graphical representation showing how waves reflect off a surface. In such a diagram, a straight line, known as the incident ray, is drawn to represent the incoming wave approaching the surface. At the point where this incident ray strikes the surface, a perpendicular line, called the normal, is drawn. The angle between the incident ray and the normal is known as the angle of incidence. According to the law of reflection, the angle of reflection, which is the angle between the reflected ray and the normal, is equal to the angle of incidence. This principle is true for all reflective surfaces. By drawing the incident ray, the normal, and the reflected ray, one can clearly illustrate the path the wave takes as it reflects off the surface. This simple ray diagram helps in understanding the predictable nature of wave reflection. Reflection can occur in two main forms: specular reflection and diffuse reflection. Specular reflection happens when waves reflect off a smooth, flat surface, such as a mirror or calm water. In specular reflection, the reflected rays are parallel to each other, producing a clear and defined reflection, such as the image seen in a mirror. The smoothness of the surface ensures that all the reflected waves maintain the same angle relative to the normal, resulting in a uniform reflection. This is why mirrors produce sharp images, as they reflect light waves in a consistent direction. On the other hand, diffuse reflection occurs when waves reflect off a rough or uneven surface. In this case, the reflected rays scatter in different directions because the angles of the surface are varied at the microscopic level. As a result, the reflection is not uniform, and no clear image is formed. Instead, the waves are scattered in many directions, which is why objects with rough surfaces, such as a wall or a piece of paper, do not produce clear reflections. The diffuse reflection allows us to see the object from multiple angles, as the scattered light reaches our eyes from various directions. In summary, reflection is a key process that occurs when waves encounter a boundary, and it is governed by principles that can be visualized through ray diagrams. Whether reflection is specular, producing clear images, or diffuse, scattering waves in multiple directions, depends on the nature of the reflecting surface. Understanding these concepts is crucial in explaining how we perceive images and how waves interact with the world around us.